An arc fault circuit interrupter breaker was tripping when a fluorescent light fixture was turned on. The issue was isolated to the closet light fixtures by removing the bulbs and confirming that the breaker no longer tripped. A receptacle inspection was performed in the receptacle where the fixture was plugged in. It was inspected for any loose connections or damage. It was discovered that the ground and neutral wires in the receptacle were touching, creating a ground fault. The ground fault was eliminated by separating the ground and neutral wires, thus resolving the tripping issue. The arc fault circuit interrupter breaker was tripping due to the ground fault caused by the contact between the neutral and ground wires in the receptacle. Once the fault was corrected, the breaker functioned properly and the light fixtures could be operated without tripping the circuit. When troubleshooting electrical problems, it's important to follow a systematic approach. Firstly, gather information about the problem. What exactly is happening? When does it happen? What are the circumstances? Secondly, perform an isolation test. This involves identifying which part of the circuit is causing the problem. In this case, removing the bulbs isolated the problem to the circuit associated with the fluorescent fixtures. Thirdly, inspect the components. Look for any obvious signs of damage, such as loose wires, burned connections, or cracked housings. Pay close attention to receptacles, as they are a common source of problems. Fourthly, test the circuit. Use a multimeter or other testing device to check for voltage, current, and resistance. This can help you identify short circuits, open circuits, and ground faults. Fifthly, make the necessary repairs. This may involve replacing damaged components, tightening loose connections, or correcting wiring errors. Always disconnect the power before making any repairs. Finally, test the circuit again to ensure that the problem has been resolved. An arc fault circuit interrupter breaker is designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a high-temperature spark. These sparks can ignite flammable materials such as wood, paper, and fabric. Arc fault circuit interrupter breakers work by detecting the unique characteristics of arcing faults. They then trip the circuit, cutting off the flow of electricity and preventing a fire. Arc fault circuit interrupter breakers are required in many new homes and renovations. They are typically installed in bedrooms, living rooms, and other areas where there is a high risk of fire. Ground faults occur when electricity flows through an unintended path to ground. This can happen if a wire comes into contact with a metal object such as a water pipe or an appliance housing. Ground faults can be dangerous as they can cause electric shock. Ground fault circuit interrupters are designed to protect against electric shock caused by ground faults. They work by detecting even small amounts of current leakage to ground. When a ground fault is detected, the ground fault circuit interrupter trips the circuit, cutting off the flow of electricity and preventing a shock. Ground fault circuit interrupters are required in many areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. In this specific case, the ground fault was caused by the neutral and ground wires touching in the receptacle. This created an unintended path for electricity to flow to ground. The arc fault circuit interrupter breaker detected this ground fault and tripped the circuit. Separating the neutral and ground wires eliminated the ground fault and allowed the circuit to function properly. It is important to note that neutral and ground wires should only be connected at the main service panel. Connecting them elsewhere can create ground loops and other problems. Always consult with a qualified electrician if you have any questions about electrical wiring. Troubleshooting electrical problems can be dangerous. Always take the following precautions. Firstly, disconnect the power before working on any electrical circuit. Secondly, use properly insulated tools. Thirdly, wear safety glasses. Fourthly, never work on electrical circuits when you are wet or standing in water. Fifthly, if you are not comfortable working on electrical circuits, hire a qualified electrician. Several factors can cause an arc fault circuit interrupter breaker to trip. Firstly, arcing faults, which occur when electricity jumps between two conductors. Secondly, ground faults, which occur when electricity flows through an unintended path to ground. Thirdly, overloads, which occur when too much current is flowing through the circuit. Fourthly, short circuits, which occur when there is a direct connection between two conductors. Fifthly, loose connections, which can create resistance and cause the circuit to overheat. If an arc fault circuit interrupter breaker is tripping frequently, it is important to investigate the cause. Start by checking for any obvious signs of damage, such as loose wires or burned connections. If you cannot find the cause of the problem, hire a qualified electrician. Several things can cause a ground fault circuit interrupter to trip besides a ground fault. Firstly, moisture. Moisture can create a path for electricity to flow to ground, causing the ground fault circuit interrupter to trip. Secondly, faulty appliances. Appliances with damaged wiring or faulty components can leak current to ground, causing the ground fault circuit interrupter to trip. Thirdly, loose connections. Loose connections can create resistance and cause the circuit to overheat, which can also cause the ground fault circuit interrupter to trip. Fourthly, nuisance tripping. Sometimes ground fault circuit interrupters can trip for no apparent reason. This is often caused by electrical noise on the circuit. If a ground fault circuit interrupter is tripping frequently, it is important to investigate the cause. Start by checking for any obvious signs of damage, such as loose wires or burned connections. If you cannot find the cause of the problem, hire a qualified electrician. When working with electrical circuits, it is important to understand the difference between neutral and ground wires. The neutral wire carries the return current from the circuit back to the source. The ground wire provides a path for electricity to flow to ground in the event of a fault. The neutral wire is typically white or grey in color. The ground wire is typically green or bare copper. It is important to never connect the neutral and ground wires together except at the main service panel. Connecting them elsewhere can create ground loops and other problems. The National Electrical Code provides specific requirements for electrical wiring. It is important to follow these requirements to ensure the safety of electrical installations. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect the latest technological advancements and safety standards. It is also important to ensure that all electrical work is performed by a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary training and experience to do the job safely. A qualified electrician will be familiar with the National Electrical Code and will be able to ensure that the electrical installation is safe and up to code. When troubleshooting an electrical circuit, it is helpful to have a multimeter. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. To measure voltage, connect the multimeter probes to the 2 points you want to measure the voltage between. Set the multimeter to the appropriate voltage range. The multimeter will display the voltage between the 2 points. To measure current, connect the multimeter in series with the circuit you want to measure the current in. Set the multimeter to the appropriate current range. The multimeter will display the current flowing through the circuit. To measure resistance, disconnect the power from the circuit you want to measure the resistance of. Connect the multimeter probes to the 2 points you want to measure the resistance between. Set the multimeter to the appropriate resistance range. The multimeter will display the resistance between the 2 points. When using a multimeter, it is important to follow the manufacturer's instructions. Be sure to select the correct voltage, current, or resistance range. Also, be careful not to touch the metal probes while the multimeter is connected to a live circuit. This could result in electric shock. In the scenario described, the hot check indicated a problem with the receptacle. A hot check involves using a voltage tester to check for voltage at various points in the circuit. In this case, the hot check revealed that the ground was touching the neutral in the receptacle. This is a dangerous condition that can cause electric shock. The receptacle was then cleared, which involved separating the ground and neutral wires. This resolved the problem and allowed the arc fault circuit interrupter breaker to function properly. In addition to separating the ground and neutral wires, it is also important to ensure that all connections are tight. Loose connections can create resistance and cause the circuit to overheat. This can lead to electrical fires. When tightening connections, use the proper torque. Too much torque can damage the connections, while too little torque can cause the connections to loosen over time. The recommended torque is specified by the manufacturer of the electrical components. It is important to use a torque wrench to ensure that the connections are tightened to the correct torque. It is also important to inspect the wiring for any signs of damage. Damaged wiring can be a fire hazard. If you find any damaged wiring, it is important to replace it immediately. When replacing wiring, use the correct size and type of wire. The size of the wire is determined by the amount of current it will carry. The type of wire is determined by the application. It is important to consult the National Electrical Code to determine the correct size and type of wire for your application. Several different types of electrical boxes are available. The type of electrical box you use will depend on the application. Some common types of electrical boxes include metal boxes, plastic boxes, and surface-mounted boxes. Metal boxes are typically used for wiring in walls and ceilings. Plastic boxes are typically used for wiring in damp locations. Surface-mounted boxes are typically used for wiring on the surface of walls and ceilings. When installing electrical boxes, it is important to follow the manufacturer's instructions. Be sure to use the correct type of fasteners to secure the box to the wall or ceiling. Also, be sure to leave enough space inside the box for the wiring. Several different types of electrical connectors are available. The type of electrical connector you use will depend on the type of wire you are connecting. Some common types of electrical connectors include wire nuts, crimp connectors, and push-in connectors. Wire nuts are typically used to connect two or more wires together. Crimp connectors are typically used to connect wires to terminals. Push-in connectors are typically used to connect wires to devices. When using electrical connectors, it is important to follow the manufacturer's instructions. Be sure to use the correct size and type of connector for the wire you are connecting. Also, be sure to tighten the connector securely. Several different types of electrical tape are available. The type of electrical tape you use will depend on the application. Some common types of electrical tape include vinyl tape, rubber tape, and cloth tape. Vinyl tape is typically used for general-purpose electrical insulation. Rubber tape is typically used for splicing wires. Cloth tape is typically used for wrapping cables. When using electrical tape, it is important to follow the manufacturer's instructions. Be sure to apply the tape tightly and evenly. Also, be sure to overlap the tape by at least 1/2 inch. When working with electrical circuits, it is important to be aware of the dangers of electricity. Electricity can cause serious injury or death. Always take the necessary precautions to protect yourself from electric shock. One important safety precaution is to always disconnect the power before working on any electrical circuit. This will prevent you from getting shocked if you accidentally touch a live wire. Another important safety precaution is to use properly insulated tools. Insulated tools will protect you from electric shock if you accidentally touch a live wire. It is also important to wear safety glasses when working with electrical circuits. This will protect your eyes from flying debris. Finally, it is important to never work on electrical circuits when you are wet or standing in water. Water is a good conductor of electricity, and it can increase your risk of electric shock. If you are not comfortable working on electrical circuits, hire a qualified electrician. A qualified electrician has the necessary training and experience to do the job safely. Electrical codes and regulations are in place to ensure the safety of electrical installations. These codes and regulations are constantly being updated to reflect the latest technological advancements and safety standards. It is important to be familiar with the electrical codes and regulations in your area. You can find information about electrical codes and regulations on the website of your local government or from a qualified electrician. Electrical safety is everyone's responsibility. By following the safety precautions outlined in this document, you can help to prevent electrical accidents. Remember to always disconnect the power before working on any electrical circuit. Use properly insulated tools and wear safety glasses. Never work on electrical circuits when you are wet or standing in water. If you are not comfortable working on electrical circuits, hire a qualified electrician. By taking these precautions, you can help to ensure your safety and the safety of others. The scenario highlights the importance of proper wiring and grounding in electrical systems. A seemingly minor issue, such as the neutral and ground wires touching in a receptacle, can have significant consequences, including tripping breakers and creating potential safety hazards. Regular inspection and maintenance of electrical systems can help to identify and correct potential problems before they lead to more serious issues. This includes checking for loose connections, damaged wiring, and proper grounding. If you are not qualified to perform electrical work, it is always best to hire a qualified electrician. An electrician has the training and the experience to identify and correct electrical problems safely and effectively. They can also ensure that your electrical system is up to code and meets all safety requirements. Proper electrical safety practices are essential for protecting yourself and your property from electrical hazards. By following these practices, you can help to prevent electrical accidents and ensure the safe operation of your electrical system. Always be aware of the potential dangers of electricity and take the necessary precautions to protect yourself and others. Electrical systems are complex and require specialized knowledge to maintain and repair. If you are unsure about any aspect of your electrical system, it is always best to consult with a qualified electrician. They can provide you with expert advice and assistance to ensure the safe and efficient operation of your electrical system. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always be respectful of electricity and take the necessary precautions to protect yourself and others from electrical hazards. By following these guidelines, you can help to create a safe electrical environment for yourself and your community.